Hey everybody, we're going to practice factoring today. I'm going to have this already written out for you because it'll take too long to write out. But just remember, when we're factoring, you want to see if you can pull out a greatest common factor first, always. And then if there is a negative on that leading coefficient, that x squared term, you want to make sure you're at least pulling out a -1 as a greatest common factor. Okay. Then for our trinomials, remember we set up our 2x2 box and our x box. And then binomials, that's two terms. You're looking for a difference of squares in that case. And your answer has the two parentheses, one sign plus, one sign minus. Okay, so let's go ahead and get started. We always want to look for a greatest common factor. And we do have one. The greatest common factor here is 10. So we're going to pull out our greatest common factor, and we set up one parenthesis. And to figure out what goes in the parentheses, we divide everything by the greatest common factor. So here we're going to have n squared. Here we're going to have a positive 10n. Here we're going to have a positive 25. Now you want to see, can I factor this trinomial again? And I can. So I'm going to set up my 2x2 box. N squared goes here, 25 goes here, multiply them together, but there's nothing but a 1 there. So the 25 goes on top. Remember, I'm trying to multiply two numbers to get to 25. The middle term goes on the bottom. I'm trying to combine or add to get to those. So I need my magic numbers. My magic numbers are 5 and 5, because when I multiply, I get 25. When I add, I get 10. Don't forget to put your variables in these other two boxes. We're going to put our 5 and 5 there. Now we're going to do greatest common factors across and down. So GCF here is n, here it's 5, down the first column is n, down the second column is 5. So we're going to set up two parentheses. We've got an n and a 5 and an n and a 5. Don't forget, anything that came out as a greatest common factor is part of your answer. And I look here and both of my signs are positive. And just keep in mind, if you have the same factors, they can be written in a condensed form like this. Okay? All right, wanted to throw a hard one out at you so we can talk about how to look this stuff up on the calculator. First of all, we do have a greatest common factor here. I'm going to pull a negative out since that leading coefficient is negative. And 6 will go into all of these terms. We'll set up a big parenthesis. I'm going to divide everything by -6. And what that negative is going to do is change the sign. So this is going to be a positive 5n squared. This is going to be negative 48n when you divide. And this is going to be a positive 64. Okay, now trinomial, I'm going to factor with my 2x2 box. So I've got 5n squared here, 64 here. Now I multiply together, and I'm just going to put my n's here. I multiply together, and I'm going to get a rather large number here. 5 times 64 is 320. So I need my magic numbers to multiply to get to 320 and combine to get to -48. Okay, so this is a rather large number. We would hope that maybe this would be done with a calculator active problem. So what you're going to do is you're going to go to y equals, and you're going to put in this top number 320 divided by x, and there's your x. Okay. And then you're going to go to the table. So we're going to go to second table. And what you're doing is you're scrolling up and down and looking at the pairs of numbers that are integers. And we need to get to 48 when we add those. Well, when I add these, that's 36. Let's go up a little, see if we get to any numbers here. That's going to be 42. And here we are, a 40 and an 8 and I need for them to be negative when I combine them. So notice these two need to be negative. When I multiply a negative times a negative, I get a positive 320. When I add the negatives, I get a negative 48. Okay, so now let's pop these in. Negative 40 and negative 8. We're going to do greatest common factors. So here it's going to be 5n. Here it's going to be 8. Here it's going to just be n. And here it's going to be 8. So we're going to set up our two parentheses. We have a 5n and an 8 in one parenthesis, an n and an 8 in the other. I look here, both my signs are negative, so I need minus signs here. And don't forget that original greatest common factor you brought out is a part of your solution. Not going to do this one. It's another one with big numbers, so I just demonstrated how to do that on the calculator, so we'll skip that. Okay, for this one, notice your r squared term is in the back. Feel free to rearrange these. Just make sure you keep the signs with them. So I'm going to put the positive 9r squared in the front, and then the linear term, 51r, and then the constant 30. Greatest common factor, there is one. It's a 3. So I'm going to divide by 3 here to figure out what goes in my parenthesis. So we're going to have a 3r squared. Here we're going to have 17r, and here we're going to have 10. Okay, so now we're going to factor that trinomial. 3r squared goes there, 10 goes there. We're going to multiply, and when we do, we get 30. And then 17 is what I'm adding to get to. And let's put our r's here. So I need factors that multiply to get to 30, but add to get to 17, and they are 15 times 2. Let's put our 15 in there and our 2 in there. Okay, greatest common factors, 3r and 2r and 5. Both signs positive, so we need pluses in here, and don't forget we pulled a 3 out. All right. Okay, let's flip over on the back. All right, notice these are binomials. They're two terms. Okay, so when we have two terms, we're not going to use this method. You actually can use this method, but it's just much easier just to know what the pattern looks like when you are setting up your factors, and it's just much easier to do it that way. First of all, we need to ask ourselves, do we have a greatest common factor here? We actually do. The greatest common factor here is 4, so I'm going to pull that out, set up a parenthesis. We're going to divide by our greatest common factor. Here we're going to have 25n squared, and here we're going to have 4. Okay? Now, perfect square, perfect square, perfect square, and a difference of squares. So this is a difference of squares. Okay? And you have a list of your perfect squares in your notebook. So when we know we're doing difference of squares, we just set up two parentheses. One of the signs is a plus, one of the signs is a minus. I'm going to go ahead and bring that 4 down. Okay, so I need my perfect square factors. So this is going to be 5n and 5n. Perfect square factors means they're the same numbers. Okay, sorry, this keeps doing that. I don't know why. Okay, so first, this is the first term, so the 5n's go in the first slot. Perfect square factors for 4 are 2 and 2. Last term goes in the last slots. We cannot factor these anymore. One indicator that they can't be factored anymore is because this has a power of 1. There's no way to break an n down with a power of 1. Okay? All right. This little fella here. There is no greatest common factor. but it is a difference of squares. So we need a plus sign and a minus. Factors of 1 are 1 times 1. They go in the front slots. And factors of a squared are a, and they go in the back slots. And we can't factor that again. Okay? All right. There is no greatest common factor here, but this is a difference of squares. These are perfect squares, and the power is an even number, so perfect square. So I'm going to set up 2 parentheses. Okay, this is going to break down into 9x squared and 9x squared. They're going to go in the front slots. 1 sign plus, 1 sign minus. 16 breaks down into 4 and 4. They're going to go in the back slots. Okay? Now, what we've got to be careful of is this can actually be factored again. These are perfect squares, and it is a difference of squares. Okay? Now, this is a factor. It cannot be factored again because that's a plus sign. So, keep in mind, this is still a part of my answer. It is one of the factors. We just cannot break it down anymore. Now we're going to break this one down. So we're going to set up our 2 parentheses, 1 sign plus, 1 sign minus. This is going to break down into 3x and 3x. It's going to go in the front slots. And that's going to break down into 2 times 2. It's going to go in the back slots. Cannot factor again. That's a power of 1 on that, and these are not perfect squares anymore. So there's your fully factored form. Okay. Okay, here we've got a greatest common factor. It is 4. So I'm going to pull that out and set up a parenthesis. I noticed when people were doing this, they were trying to skip this step and go ahead and set up your 2 parentheses for dots. Don't do that. Make sure that when you factor by the greatest common factor, you set up 1 parenthesis and go through this step first. So we're going to divide by 4 here. So that is going to be 100 minus 9v squared. Okay. Notice this is a difference of squares. So 4 is one of my factors. It comes down as one of my answers. Now I'm going to set up the 2 parentheses, 1 sign plus and 1 sign minus. The 100, the perfect square factors, are 10 and 10. And for the 9v squared, it's going to be 9v and 9v. And they go in the back slots. Okay? All right. We have a greatest common factor here. It is actually 9v squared. So we're going to set up 1 parenthesis. We're going to divide by 9v squared here. Okay, remember we subtract powers. So we have a v squared, and 81 divided by 9 is 9. And here we have minus 100, and the v squareds cancel. Okay, can I factor this again? Yes, I can. These are perfect squares. It's a difference of squares. We're going to bring down the 9v squared as part of my answer because it is a factor. 1 sign plus, 1 sign minus. This is going to break down into 3v and 3v. It goes in the front slots. And this breaks down into 10 and 10, and it goes in the back slots. Okay? All right. You guys have a good day.